We're looking at the last section of notes for topic 5, the last section in the packet. That is, we've got we've got the centers of triangles as our topic and our essential question here. How do you find the center of a triangle? Okay, how do you find the center of a triangle? And the answer to that question is, well, it depends. All four of the things that we're going to look at today, depending on how you look at it, could be considered the quote unquote center of a triangle. So we're going to look at all four of these possibilities and discuss where each one comes from and and what they look like. Okay, this today is just a general overview, a large scale overview of what these things are. It doesn't necessarily tell us um, how it's going to go when we look at the problems for this on Canvas. That will be on our next video where we go over the condensed version of all this information. But this is this is all good information. It's a good overview of what we have with centers of triangles. So, first thing is the centroid. It is the intersection point of the three medians. Now, the medians, important to note here, a median is a line that connects the vertex of a triangle, so right here, to the midpoint of the opposite side. So if we do like that and drew that line right there, we do the same thing from this corner up to this midpoint. We do the same thing from this corner to this midpoint. And that makes it to where all of these things, remember what the midpoint is, okay? It's the point in the middle of this side. So let's try that again. So that and that are the same. This one and this one are the same. And those are the same. All right, that's what a median is. It connects the vertex to the midpoint. All right, three of the things that we're going to talk about today, the orthocenter, centroid, and circumcenter, are always in a straight line with the centroid in the middle. The centroid is always inside of the triangle. The centroid is also the center of mass or balancing point of the triangle. So if you cut this triangle out, like had a cardboard cutout of this triangle, you could balance, if you found the centroid, you could balance that thing just on a pencil point. That would be the center of mass of that cutout. All right, here's a little bit better diagram of it. You notice that we've got the vertex connected to the opposite midpoint, and we can tell it's a midpoint because this side and this side both have 3 hash marks, so they're congruent. All right, when you do that for all 3 corners, all 3 midpoints, they meet in this one point in the middle. That's called the centroid. Moving on now to our next one is called the orthocenter. The orthocenter is the intersection point of altitudes of the 3 sides of your triangle. So an altitude, another word for that would be height. Another word for that would be height. Now we know what the height of a triangle is, okay? When we talked about way on back in middle school math, you talked about the height because of that formula for the area. The formula for the area was base times height divided by 2. Okay, you've heard of the height of a triangle, and the way you found the height was by starting at the corner, and you would drop it straight down to the other side. You connect the corner to the opposite side so that it made a right angle. Okay, you couldn't just use the side length as the height. It had to be a perpendicular side length. Okay, it had to be a perpendicular distance from the point to the opposite side. And so when you make that height, when you connect the vertex to the opposite side in a perpendicular setup where it makes right angles, when you do that on all 3 of the corners, all 3 of the sides, they meet in this point in the middle. That point in the middle right there is called the orthocenter. Go on now to our next one. Our next one is called the incenter. The incenter is the intersection point of the angle bisectors. So we know what that word bisect means, right? That word bisect means you cut it in half. So if you drew lines across from each of the three angles, if you drew a line across to right there, one across to right there, so that all of these angles got cut in half, got cut into two other smaller angles that were the same size, those three bisectors would meet each other in the point called the incenter. The incenter is always inside of the triangle, and this last bit of information is pretty interesting. It is the center of the circle that could be inscribed in the triangle. So what that means is this. All right, we've got our angle bisectors here, and we know that this line, all those lines cutting across the triangle, we know that they're angle bisectors because this angle here and that angle there both have three arcs, so they're congruent. This one and this one both have two arcs, so they're congruent. This one and this one have one arc, so they're congruent. We know that it's angle bisectors because it's split them all into two equal size angles. Okay? That point right there in the middle is the incenter. Now, this little bit of information down here at the bottom, the incenter is the center of the circle that could be inscribed. What that means is if you took a circle and you made it the size that the edge of the circle would touch all three sides of the triangle, just like this, okay? The edge of the circle, the outside of the circle, touches all three sides of our triangle. The center of that circle, right there, is the incenter of the triangle. That's not necessarily something that we're going to try and make and try and draw a whole bunch, but it is interesting how that works together. This next one is what's called the circumcenter. It is the intersection point of the perpendicular bisectors. Now, that's another term that we've heard before. Bisect, like we said a little while ago, means cut in half, and perpendicular means that it makes right angles. Okay? The circumcenter is equidistant from all three vertices. That's another word we've heard before. Equidistant sounds just like equal distance, right? That's exactly what it means. The same distance from all three vertices, all three corners of the triangle. And that distance is the radius of the circle. That's talking about this circle that's in this little nugget of information over here. The center of the circle, the triangle could be inscribed within. So here's what that looks like. If you set it up, first of all, look at the picture as it is. Okay, the picture as it is, it takes it to where all three lines are perpendicular and all three lines are cutting the sides in half. Okay, it doesn't show it, but that's what it is. If they're perpendicular bisectors, that means that one and that one are the same. That means this chunk and that chunk are the same, and it means these are the same. Okay, that's what a perpendicular bisector is. It means those pieces are congruent to each other. Now, what it's talking about with the circle is that if you drew a circle where all three corners of your triangle are on the edge of the circle, just like that, the circumcenter is the middle of this circle. And it makes it to where the distance, that means from the distance from the corner of the triangle to the middle is the same for all three corners because it's the center of that circle. All right. That right there is just the general overview of these four things. The next thing we look at the next video that's posted is going to be looking at a more condensed version of this information and something that hopefully will be more closely related to the practice problems that go with it. Hopefully be a lot more helpful to you. All right. Y'all have a good one. Take care. We'll see you again later.